nyepamnene kudlukula nyepangiragala gena nyepamnene kudlukula ibuloke nomoto nibeti sola ibuloke ndato nibetoto
Mingi Congo
Lamin
na
Lamin te jibe norin te nyamen Lamin
kabana wulokono
wulokono nyinta mo Lamin
pabilenki
muna ngata afamole
haina
ngata Ngoto le Fabrama
Mingi baba nyole
Ngoto le Fabrama
Namu jumara kan kuma diteng.
Fabrama
Jumara mu.
ndele bare muso
Lunda mana.
Famo kata
Jamani mbere.
Alindo ko
Jamani.
bari ngoto mon kontande
Bari jamani fana na mundu wa kontan.
ngoto minaka ngalamin je fom filitala lamin jibe nori nyaami
Lamin ila siran sama ne benki. Yala so tol sayndi no ko mo lokko momo.
ngoto
Nam.
itedinte yalo ne lamin hakkilo diata bake karambu ngoto anu santeng ministry ko di ngole si suko na amanke ko do holi
Sibitun.
bagona de
ala ni ko kede namo ballo
ala ni na ko ina karta bulo be damen ala ni je.
ngoto
Nam.
ngoto mon kontan fere
Jamani mu ne keda.
ifika lamin ki wulo ko no nyinta mon ko do fete malo lamin nyanta sila la be la moy kala karango
Jamani karamol be sorande ne ko fasita wulo ko nako.
baba
karambu wol ma soron ni ko karambu wol soron da amanke kom holiday lem ngoto dini ngo nyanta sila la ala karango la moy yamen kamen fue man kontan anda mande
alla nyin kombo courant adanda la kombo len do la jankara mol le soronda doron kamen courant ma rado la kombo e ko ndol fana na kara mol soron je kara mol soron lamina dara lo nyino la aman kara fe na sokon ala munekela
am lamin ite foyde malon kon le sinol be ke kar radio to
nga fine
e ko yana di mod lamin ya mu na fonye
bir kabin mina kan ndamita nteri maning fatu
ha
ndambe la sugal ala dinol be siri be la moy ka
faru danso am fana tambira jele ni subala la ngaje dini ngol be jet talanta nen kili warol e be serin jelen
sa lamin fadante ku kili wo ke no la ba lamin bi taka wulo ko no nyin taymo alami
aman dara fenela
ite dine ko ni man si yakari la suno la moy radio to e balon nan
muneka ke afonye ba nyara ni alon
telentel jikot
afonye ba munebe ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko lamin mañana tala wulo ko adu karam mo be so da fa ñembe kala
ko to wole nati bawo ngalle ni lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinne ko e si suwo kono bari ni ko e si suwo kono ibe karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto da bongo bar radio be bulen koto batiri sanga ay si ay alamo
sa do kala
nyaadi ko ta o bulaji
abe o kala nyaadi
kamun ke nyaadi
radio abe wala moy la ibe mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karande
ila subject ro baby jele baby jele
wala nan ka coco moy fa danse wolya ngombe tambi kana ngadi ningol de be ikadum bungo de ko kada fa mo
asototal de
la min mala be kara wala de
bari lafta ideal on ko inde every year second wala fourth
muna ni ko de ko folle sinila ba ndele sinilo ne ba
say mba foke en koto wala fango yen wulindi yalo famo keta bat ñu fanam bulata ko ko me yen nati jambi la min nyanta karana ndel beji ko be nyineka ya bulay kara wulo kana ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wala ka munda kara mo man soro la men nyanta kara si so na regular
la sila le ayala le sino
dal ko korno ko smolon
kilar ya
ma be ngala ko momo say mi do ni ko no kera
mengi bruzo
ndelo ko do la da ba rosa no radio ba no bari woro radio ni abe jele ba do ngamra do man nembe buljan dala nyara nyar wo ko fendi mo la ba min tayra ba rosa
bara te ku folo ajibe nori nya labi tamete ku
muna na de
teku
bari ko do famo ke
imagine nañu ñambol si sol le keje kisiki man si sol no le kafun ka ñoma bari ñambu kino li mañana ka finde ni nambe ko so la ga
ngalle limbeta de be ñambo do dilanna
ñara ni ko rim fennat ñara nata
bari famo ke da
ngata bungono tambi bungono ñara mel ngando ko fele ko ke baru nganda ni pelo la ndija bungono bismillah bisu diara
ye fongo tanka sina dolu tanka korota korota
Hello, viewers and listeners. I'm Samuel D. Koide. We're about to continue our lessons on electric forces and Coulomb's law. Today, this lesson will be relevant for grade 11 and 12 also. So, our topic of discussion today is electric forces, and we want to see what force exists. Remember what we have done so far by trying to identify the force of repulsion and attraction between. We said when like charges come closer to each other, they repel each other. Unlike ones, we attract each other. So there's always a force existing between the charges there. So those forces, let's say we have a charge here, another charge here, and they are separated by some distance. Their centers are separated by some distance there. Now, what happens to this charge? This is, let's say, Q, charge 1 and charge 2, both positive. Remember, this force is going to be a repulsive force. Now, there is going to be a force between them. That is either repulsive or attractive force. So, Coulomb's, Charles de Coulomb, a scientist, was interested in this, wanted to know the electric force between as they come close to each other and they are separated by a distance of r. So let's see what he said here. He said that the force that is existing between the two charges is going to be a product of their magnitude and also inversely proportional to the square of their distance apart. But let's first of all see what charged objects do. So remember the earlier examples of the plastic ruler, obtaining a charge and then attracting a neutral bit of paper. A neutral bit of paper, we did that before. Let's look at it at a more close and see what happens. More closely and see what happens there. What will happen to the charge on rod A if it is moved towards rod B? So let's see what will happen. When A is brought towards B, the electrons in A will be repelled. You know, electrons in A will move to the left side of the rod. This causes the left and right sides of the rod to have a different charge. Overall, the rod remains neutral. The rod is polarized. The positive next charge on the right side of A will cause A to move towards B. Opposites attracts, remember? Unlike charges will always attract. Like charges will repel. Now, see, from what I've said, there's a question here. What will happen when a neutral rod is brought near a negative charge? The neutral rod, the rod is neutral and is brought near a, what happens to a neutral rod if it is brought near a negatively charged rod? So we have two rods. This is neutral and it is brought near. This is neutral, means it has equal amount of positive and negative charges. So we have, this is neutral and this is negatively charged. So what happens there? Now you will see that there, let's go through the options. Say A, the rod will move towards each other. B, the rod move away from each other. C, nothing. The rod will remain at rest. So now if you are, this is neutral and is brought near a negative, because it's neutral, it has equal amount of negative or positive charges. So what will happen here is that the positive part of these positive charges of this neutral will be attracted to the negative charges there. So because there is negative over there and there's positive there, this neutral having the same amount of negative and positive charges, and a negative charge rod is brought near, there's going to be an attraction between them. So there's a force. That force brings them together. So the rod will move towards each other. A is the correct option there. So that's the answer to that question. Number 2, what happens to the electrons on a neutral conductor that is brought near a positive charge rod? Now, so a neutral conductor, watch out the same effect. The electron on the neutral conductor and that is brought near a positively charged rod. Now the rod is positively charged and the conductor is neutral. So watch out. This is they say what happens to the electron on the neutral conductor. So this conductor is neutral. It is having positive and negative charges in equal amount. Now what will happen? What happens when it is brought near a positively charged rod? So now if I bring it near a positive charged rod, Now the same effect happens there. So let's go through the option. All electrons move to the side of the conductor. So see, this is what happens to the electron on the neutral conductor. So let me call this neutral, so it will be easier to identify. And that is the rod. This is a charged rod. So the rod is positively charged. So let's go through the options now. All electrons move to the side of the conductor furthest from the rod. So you see, that is telling you that this is the electron, this is negatively charged. It says it will go to the other side that is further away from the rod. That is wrong answer. A is wrong. B, each electron moves to the side of their atoms closer to the rod. Of course, this electron here, this is negative charge, they go to the point that is closer to the positive charge rod over there. So each electron moves to the side of their atoms closest to the rod. B is the correct answer in that case there. So we proceed. Now we have the electric force itself that I was talking about. Now Newton's first law, that's the law of inertia, states that an object at rest will remain at rest until an external force acts on it, and conversely, if it is moving, it will continue in a uniform straight line motion until it is compelled by an unbalanced force. So now this is the same here. Of course, it is a special case of object in motion now, but object that stays in motion where the velocity of the object is 0, they will also continue in a uniform straight line until a force acts on them. That is Newton's idea. Now let's see how we can apply it here. Electric force was actually introduced sometime back in the 18th century by Joseph Priestley and John Robinson. You see those guys over there. They did a great work here, and we can see that the force between two objects follow the same principles as the gravitational force, and that is the force between two charged objects. Object depends on the inverse square law. That's the law I was trying to skip. That's inverse square law. Right? The force existing between the two charges is directly proportional to the product of that's actually their absolute values. Watch here. We are talking about the absolute values in this case, and inversely proportional to the square of their distance apart. So it is the inverse square law we're talking about here, as compared just the same as Newton's universal law of gravitation. So you look at the force is directly proportional to the product of the absolute value and inversely proportional to the square of their distance apart. So this Charles de Coulomb was a French guy, was able to publish this report that there is a force existing between these charges, and this force is equivalent to the product, or is directly proportional to the product of the masses, the absolute magnitude of their values, and inversely proportional to the square of their distance apart. So watch out for their absolute value here. It is the absolute value you're taking into consideration here. Now this is the result from that experiment done by Charles de Coulomb. Now thus the magnitude of the electric force is given by this equation. I just told you that. Now we move that proportionality sign to this a constant. So we have Q1 and this Q2 all R squared. So where Q1 are the charges, Q1, Q2, these are the charges. This is charge 1 and this is charge 2. So the two charges that are separated by this distance are having a force between them that is directly proportional to in magnitude to the product of that charge, and also the inversely proportional to the square of their distance apart. It's also called the inverse square law. So watch this out. And the proportional sign here, the constant of proportionality was discovered and was given as 9 times 10 raised to the power 9 Newton meter square per coulomb square. Watch, that is correct. So it's your K is given as the constant of proportionality, which is giving us 9 times 10 raised to the power 9 Newton meter square per coulomb square. So watch out for the constant of proportionality, which we are going to interact with much more. So that is it. Now we have the first question there. Now, first of all, before the questions, let's look at the law. It's used to calculate the magnitude of the force. Remember, I told you that the magnitude of this force is given by this formula. So this law is used to interact to give us the magnitude of that force. and it also, each object exerts the same force on each other. Watch out for Newton's third law. It says that to every action there is equal opposite reaction. Don't lose sight on that as you are entering into the Coulomb's law. Now we look at the electric force and the gravitational force. These two forces, they have some relationship, you know. They are quite different somehow, but they are all forces. So first of all, gravitational electric forces is much more heavier than gravitational force. You know, you can see that as the charges are having the smaller distance between them, so you have a massive force there. So electric force, Coulombic force is greater than gravitational force for your objective questions, so always check on that. And the other difference between the two of them is that Coulombic forces, that is the electric forces, can be attractive and repulsive, but laws of gravity, the law of gravity is always attractive. That's the major difference between the two of them. The Coulombic force, that is the force, the electric force between the charges, can be repulsive and attractive, but gravitational force is always attractive. Watch for that difference between them. So look at the electric force there. Let me go back to the star. You see, the electric force is in the order 10 raised to the power 36. It's much more massive than the gravitational force. Take note of that. So we now look at the question. The first question there says that calculate the force. The force on this, it is first is equals to, we already know, K, and that is Q1 and Q2 or R squared. So watch out for that equation. Now we have, this is 10 raised to the power 9, you know that already. From that question, we have two charges. One of them is 20 microcoulomb. So I multiply the 20 by the microcoulomb because of the microcoulomb, and I have the other guy is a -1 somewhere there times 10 raised to the power -6. That's a microcoulomb as well. Now we now have, and the distance between them is, now we change that one. This is 0.20 or square. Just converted that for you. So now if you can do the math over there, you will come out with 1.8 times 10 raised to the power -2 Newton. I have ignored that negative because I was just looking for the absolute value of the magnitude. So I did not consider the negative there. So that is what is the force on each of these, on each order. Remember, the Newton's third law says that to every action there is equal opposite action. This is the force, that is the magnitude of the force that's going to be on each of them, because they will attract or repel each other with equal and opposite forces in that case. So now we have this first example. Now the second here is to compare and contrast the electric force and the gravitational force. I just gave you that the gravitational force is far less than the electrical force. The electrical force is much more larger. That is 10 raised to the power 36 times the gravitational force. That is more massive. Electric force is more massive than gravitational force. So watch out for that. Now I give you some examples, some assignments. Your assignment reads, what is the distance between two charges plus 7.8 microcoulomb and plus 9.2 microcoulomb if they exert a force of 4.5 millinewton on each order? Watch out for the force. The force is given here and the two charges are given, and the same constant remains. So use K as this. That's an assignment for you. You can also take this other assignment if you like. So it says a charge of minus 4.2 microcoulomb charge exerts an attractive force of 1.2 millinewton on a second charge, which is of a distance 2.4 meters away. What is the magnitude and sign of the second charge? It's another assignment for you. You take K as this. Watch out for that question. So that is an assignment. You try and do the two assignments as we proceed to the next one. I'll just keep this ones and we go to the very important one, which is theoretical here. It is the interaction of the forces superpose. So we'll be able to look at the superposition of electric forces as the charges are lined up in a single file. Let's say they are on a straight line. Now when the charges appear on that straight line, what happens to the force between them? So let's see that question. It says that there is a force. So now let's look at a few examples here. Now we'll look at 3 charges that are on that x-axis. There, they are in that straight line on the normal line. This guy is at -8 and is Q1. Q1 is a positive charge, is is 25 microcoulomb, and it is located at the point -8, and you have another charge at position 0, that's at the center. There we have, that is a charge, this Q2. Q2 is -10 microcoulomb, and you have a third charge somewhere here, which is Q3, and it is 15 microcoulomb, and it is also located at the position 4 on the x-axis, and this x-axis, the distance between them is measured in meters. So now you must be able to look at all of these. Now these 3 charges are in this on this line, and the question says, now this diagram, I'll just put the diagram here for you so you'll be able to use it to solve the problems as we move. Now you see the questions. The question says, first, in solving this question, that is superimposition of electric forces, the following procedures must be followed. You must be able to isolate the charge and draw a free body diagram, then use Coulomb's law to find the forces acting between the two forces, the charges there. So watch out, you must be able to isolate each charge, and you draw the free body diagram, and you find the forces existing between them. So first question is, we have to label. First, the question says, draw the free body diagram. That was the question there. It said draw the free body diagram for each of these charges there. So as you see them over there, you have to draw a free body diagram. A free body diagram is that diagram that only shows the force on that object at that time, based upon the coulombic force that exists between the charges in that order. Let's go through this question. The charges are located at the different position, as you can see on the board there. Now the question says draw the free body diagram for the electric forces acting on charge 1, charge 2, and charge 3. So number 1 says, so let's draw the free body diagram. Let's imagine that charge, the charge Q1 is located here. You have this other charge here and this other charge here. Now let me just give it some color. So this one charge, there's another charge somewhere there, and you have another charge somewhere there. So now the charge 1225 coulomb hertz, it is a positive charge. Watch here, this is positive, this is a negative charge, and this is a positive charge as well. So the positive charge here, it's positive. So now there are 2 other charges that are in the neighborhood. So they are going to affect this charge by a force. So now you see what force they exert on each other. Between this charge and this charge, there are unlike charges. Unlike charges will always attract each other. So this charge will be forced to go this way. This will be going this way because this is negative. There's going to be an attraction between these two days, and that force that is going to make this attract towards this is going to be with respect to the second charge. It is the one creating the charge, and the force is on that first charge. So the first figure tells you who is creating the interaction, who is creating the, on whom is that force exerted. The force on this is due to the charge 2. So the force on this charge 1 is due to charge 2, and the charge 2 is the one creating that force, so it should be the first number, and the second number stays on whom the force is exerted. So the force is created by charge 2 on charge 1. That's the meaning of F21. Now that is attraction, because this one will be tempted to go this way. What about between this and this? Between this and this, there's going to be repulsion. It's going to be repulsion because this is positive, this is positive. So there is repulsion. So repulsion, this force on this, because of the repulsive nature, the presence of this charge will be able to move this charge the other way. So this force is created by charge 3. It's going to be on this, but it's going to be due to charge 3. Charge 3 is the one that is causing this force on charge 1. Here it is the charge 2 that is causing the force on charge 1. So the free body diagram for this charge is this arrow this way, this arrow this way. Here is attraction between them, here is repulsion. So this is the free body diagram for the first charge Q1. So Q1. What about Q2? Q2, I use its own color. The color is that, and that guy is negative. Now, when it's negative, watch what happens here. Around its vicinity, there's an attraction between this and this, of course. There's attraction between these. So this force, this charge will be tempted to go the other way because of the presence of this. So that force on it is going to be in that direction. So it goes that way. And the force is due to charge 1 on charge 2. The force is due to that on it. So now that is the direction of that force. So now what about between this and this? This is attraction as well. This is going to force this charge to be going this way because this is positive, this is negative, there's attraction. This should be moving that way. So the force on it is going to be in that direction. So that force is created by which charge? It is created by charge 3. On which one? It is on charge 2. This is the second charge, but the force is created by that. So we have the free body diagram for that. What about the third one? The third one is the free body diagram for the green man here. It's also is plus. It's a plus charge. It's a plus charge. So around its vicinity, there are two other charges there. Between this and this, charge 3, there is attraction. So this will be tempted to go this way because of the presence of this unlike charge. So this is going to be that way. The force on it is due to charge 2. So force on due to charge 2 on 3. And between this and this, that's going to be repulsion. So this will be tempted to go that way. So you're going to have the force is created by what? By charge 1 on charge 3. So now we have drawn the free body diagram. So draw the free body diagram for the electric forces acting on all the charges. This is charge 2 and this is charge 3. So you must be able to know how this free body diagram comes. Question 2 says, find the magnitude of the forces between Q1 and Q2. That is question number 2. Find the magnitude of the force between Q1 and Q2. So between Q1 and Q2, we have the force between 1 and 2. This is the K, that is the constant, and you have the charge for the first guy here, the second, that's it here, and the distance between them is 8. If you can look at this, this is 8 meters between that, and between 0 and 4, it's 4 meters as well. So now you'll be able to figure out the distance between this and this is 8 square. So when you do the math there, you have 2 is given by the value. If you have your calculator properly, you have 1 times 10 raised to the power. This is minus 2 Newton. Now you can verify that answer. Now it's a negative, but I'm looking at the magnitude because I've just taken the absolute value of it, so I didn't include the magnitude there, the sign there. But just know that it is going to be an attractive force because the two charges are of opposite signs. So now this is the magnitude of that. So let's check the other question. It says find the magnitude of the force between Q1 and Q3. So force due to 1 and 3. Force due to 1 and 3. It's also given by 9 times 10 raised to the power 9. 1 is 25 times 10 raised to the power minus 6. Times the positive 3 is that 10 raised to the power minus that. So we divide by between 1 and 3. The distance here is 12, so it's 12 square. So you have this time you have a positive number, so you have 2.3 times 2.3 times 10 raised to the power minus 2. So if you walk through that properly, see that this is, so you punch this answer from your calculator, you got to verify it. Now it is a plus in that case. Like I said, I'm just interested in the magnitude, so I go back to the next one, which is the third question. Says D. D says find the magnitude of the force between Q3 and Q2. So now it is between 2 and 3. 2, 3. So the same is 9 times 10 raised to the power 9. And this is the giving us, like, look at the question there. What is the magnitude of that guy? It is Q2. 2 is minus 10 times 10 raised to the power minus 6. That's microcoulomb. This is guy. And 2 is multiplied by 15 times 10 raised to the power minus 6 microcoulomb. So we divide that 2. So you must be able to look at the distance between 2 and 3. Distance between 2 and 3 is 4. So 4 square. So remember, 1 is negative over there, so you must be able to, if you punch that properly, you have 4 times 10 raised to the power minus 2 Newton. It's also negative. because of that guy over there. So now you have that magnitude. So let's go to the next slide. This is E. It says find the magnitude and direction of the net force on Q3. So last question, E, use net force on Q3, and the net force on Q1. Q1 has F31 and F21. So Q1 will have, Q1 is having F21, F31 plus F21. So remember the link between them. From Newton's third law, to every action there is equal opposite reaction. That will give you an idea of this. And F is 21 equal. Then you have F13 is the same as F31, and F23 is the same as F32. That is from Newton's third law, to every action there is equal opposite reaction. So watch out for that. So now I have F31. F31 is given by this. That's a plus. So you have total is 2.3 times 10 raised to the power minus 2. And F21 is a negative value in that case. So it's minus 3.5 times 10 raised to the power minus 2. So F for Q1, the total force on it is going to be this. So you must be able to look at the two questions there. If you add that, you'll be able to get the 2. So the same for Q2. Q2 also, you add up the two answers. That is Q2 is F12 plus F32. So F12 is F12 plus F32. So now if I add the two, F12 was giving us 3 minus 3.51 times 10 raised to the power minus 2 plus, and I have F32, F23 is the same as F32, so I have 8.44 times 10 raised to the power. Now you can get that answer for yourself. Now you have Q3, the total force on Q3 is having total F23 is given there as 8. It's a negative 8.44 times 10 raised to the power minus 2 plus, and F13 is 2.3 times 10 raised to the power minus 2 Newton. So if you evaluate all of that, you'll be able to see that this one is going to obviously be a negative number. This would be somewhere a positive number. And to have this was negative, so we have a resultant negative here. So if you check this is going to be a resultant. This is bigger, it's going to be a plus answer. This one is going to be a plus answer, so it is right. This one is the direction. This is also a plus answer. It will be to the right. If you punch this from your calculator, maybe you have a negative answer. If you have a negative answer, then it's going to be to the left. So you punch out the verify. If your final answer is a negative answer, then you see on the number line the negative in the left of the 0 and the positive is to the right of the 0. So this, if this is positive also, this is going to be to the right, and this is right. Positive is right and negative is left. So watch out for the direction. So you say find the magnitude and direction of the net force on all of them. So if you punch this from your calculator, you discover a negative answer, then it's going to be the direction of that net force is going to be in the left, because the negative on the number line is describe the direction towards the left. It's negative towards the left. The left side of the number line is not left side of the 0 is always negative. Now if your total sum of the forces, when you punch it together, if you have a positive answer, then you have the net force moving in the direction towards the right. So towards the right, and this is towards the right. When it is positive is right, when it is negative is left. So when you punch this, you'll be able to verify that. So I'll now stop here for this lesson, so that I wanted to give you some assignment so that you also interact with it. But because of time, I'm going to stop here for today, and we can continue this lesson some other day. So watch out for the next lesson. Thank you for your audience.